In this video, I'm going to be talking about implicit differentiation with equations that don't involve y or x. And therefore, it sometimes becomes a little bit more difficult to tell which is the dependent variable, which is usually y, and the independent variable, which is usually x. So if you have an equation that does not have an x and a y, you have to look for some clues as to which is the dependent and which is the independent variable. Because when these equations are written implicitly, it is very difficult sometimes to tell. As in the case of this equation, we have no way of knowing just by looking at this equation which is the dependent variable and which is the independent variable. So we have to look at the wording of the problem. It says find the rate of change of S with respect to R. That means that S is changing with respect to how R changes. Now, how would we write that as a derivative? Well, as a derivative, if S is changing with respect to R, we would write that as the change in S with respect to R, or in other words, ds dr. S is changing with respect to R. This is implying then that the variable in the numerator is dependent and the variable in the denominator, R, is the independent variable. And so, therefore, we now know how to go about doing our implicit differentiation, knowing which is the dependent and which is the independent variable. So let's do that. So R here, 6r squared, we want to take the derivative of that. Well, R is the independent variable. So that's simply going to be 2 times 6 is 12r. However, 5s, s is the dependent variable now. So the derivative of that would be 5 times s prime. And then 8 is just the constant. The derivative of the constant is 0. And now we just solve this for s prime. So we have 5s prime is equal to negative 12r, or s prime is negative 12 over 5r. Let's do one more example. In this next problem, we have v's and w's. How do we know which is the dependent and which is the independent variable? Well, we look at the wording of the problem. Find the rate of change of w with respect to v. That means w is changing with respect to v. So therefore, w is the dependent and v is the independent variable. So when we take the derivative, we have to take them accordingly. So let's take a look at the first term here, 4v squared times w. V is the independent variable, w is the dependent variable. So we're also going to have to use the product rule here. So my first function here is 4v squared. That is independent, so the derivative of that is 8v. And we multiply that by w plus 4v squared times the derivative of w, which is the dependent variable. So that would be 1 times w prime minus the derivative of 5w squared, which is again the dependent variable. So that would be 10w w prime. And the derivative of 2 is 0. So we have w primes in these two spots, and so we now need to just solve this for w prime. So we'll take this and put it over on the other side. So we have 4v squared w prime minus 10w w prime, and that is equal to negative 8v w. Factoring out the w prime, we have 4v squared minus 10w is equal to negative 8v w. And then dividing by all of this, W prime is negative 8VW all over 4V squared minus 10W. And it doesn't look like there's anything. We could factor a 2 out of the numerator and cancel it with a 2 in the denominator. So that would give us a negative 4VW over 2V squared minus 5W. But that looks like about the most we can do to reduce that. So our final answer is W prime is equal to this. So that is how you tell which is the dependent and which is the independent variable, either by the wording of the problem like I showed you here, or sometimes you'll be given this. And so if you're given the derivative notation in Leibniz notation, the variable on top is dependent, the variable on the bottom is independent.